Hello, sleepy traveller of the sea. Welcome to the Sleepy Oceanographer. Whoa. A place where science drifts like a soft current and wonder sleeps just beneath the waves. Tonight we're gently diving into the deep, shadowy world of the octopus, a creature so mysterious that it seems like it belongs to another planet. Did you know the octopus has not one but 9 brains? One in its head, and one in each of its 8 arms. Before we float into this soothing story, let me know, into the comments, where in the world are you watching from tonight? I'd love to know where our sleepy explorers are tuning in from. Now, take a deep breath and let's begin. The octopus is one of the most quietly extraordinary creatures in the ocean, and perhaps the entire animal kingdom. With its soft, flowing body and watchful eyes, it moves like liquid thought. Never rushing, never frantic, always aware. It drifts through coral gardens and rocky dens with a grace that belies its complexity. If you didn't know any better, you might mistake it for just another sea creature, adapted to hide, escape, and survive. But beneath its shimmering camouflage and cloud-like movements lies something unexpected. A mind. A mind not just clever, but profoundly alien and yet somehow familiar. From the moment scientists began observing octopuses closely, something became clear. This was not an ordinary animal. In laboratories and aquariums, octopuses would do things that surprised their human observers, things that suggested curiosity, memory, playfulness, even problem-solving. They would unscrew jars to get to food, escape from closed containers, rearrange their environments, and sometimes even squirt water at lights they found annoying, not out of instinct, but preference. Some researchers began to notice that the octopus didn't behave like other invertebrates at all. While a crab might scuttle and a snail might slide, both driven mostly by reflex and repetition, the octopus seemed to choose. It explored its surroundings as though it were genuinely interested in them. It didn't just react to its environment, it interacted with it, sometimes in unexpected ways. Imagine finding an octopus that has learned how to open a childproof container, or another that plays with a floating bottle cap, not for food, but for fun. These aren't just reflexes, these are hints of something deeper. What makes this so surprising is that biologically the octopus is nothing like us. Unlike mammals, birds, or even fish, the octopus belongs to a group called mollusks, relatives of clams, oysters, and snails, creatures not exactly known for their intellectual flair. And yet, here is the octopus, outperforming even some dogs in certain problem-solving tests. It's as if evolution had taken a completely different path, not through fur and warm blood and backbones, but through soft tissue, flexibility, and a brain that developed in total isolation from ours. In fact, the last common ancestor between humans and octopuses lived over 100 million years ago, likely a small, worm-like creature that had no brain at all. That ancient split in evolutionary history means the octopus is what some scientists call an intelligent alien on Earth. It evolved its brain completely independently from vertebrates, and yet somehow arrived at something so sophisticated it still puzzles us. Its eyes, for instance, are eerily similar to ours, not because we share a common design, but because nature, in its strange brilliance, came to the same solution twice. Convergent evolution. It's as if the ocean whispered to the octopus, "You'll need to see to survive," and the octopus responded with optical clarity. But vision is only part of the story. What truly sets the octopus apart is the way it seems to process the world and respond to it with intention. Scientists have documented octopuses displaying unique personalities. Some are shy, others bold. Some are quick to explore, others prefer the shadows. When they solve problems, they don't always do it the same way. Each octopus appears to have its own preferred strategy, its own quiet quirks. Perhaps most striking of all is how the octopus expresses intelligence through its body. With no bones and a flexible form, it can squeeze through spaces no larger than its eye. It can change the colour and texture of its skin in an instant, becoming smooth like a pebble or rough like coral. But this isn't just camouflage. In some cases, the octopus will change its skin even when alone, perhaps experimenting, practicing, or even dreaming. It's here in the stillness of observation that the octopus reveals itself not just as an animal of the sea, but as a kind of quiet genius. It does not use words, it does not build tools, but it solves, it feels, and in its own way, it wonders. And maybe that is why people who spend time with octopuses often speak of them with awe, respect, even affection. They are more than animals, they are minds, drifting, reaching, sensing, in a form utterly unlike our own. And yet, when you look into an octopus's eye, dark and depthless, you may feel something ancient and mysterious looking right back at you. Something that reminds you that intelligence isn't ours alone, it belongs to the world. And in the silence of the sea, in the slow, deliberate dance of a creature with arms that think, the octopus shows us what intelligence might look like in a very different kind of body. The idea that the octopus has 9 brains sounds like something out of science fiction, and yet this strange truth is grounded in biology, a result of millions of years of evolution in the quiet, dark corners of the sea. At first glance, the concept seems almost unbelievable. How could one animal, so soft and delicate, house not just 1 brain but 9? But to understand this, we have to look not just at the anatomy of the octopus, but at the demands of the life it leads, a life of constant motion, camouflage, exploration, and adaptation. Let's begin at the centre. Inside the octopus's head, nestled between its eyes, is the central brain. This is the part most similar to what we imagine when we think of the brain, a large cluster of neurons responsible for processing complex tasks, forming memories, planning movement, and making decisions. This central brain is sophisticated. It allows the octopus to learn from experience, to remember, and even to recognize individuals. It is the command center, the place where the animal's personality and higher-level cognition seem to reside. But unlike in most animals, the central brain of the octopus is not the sole ruler of its body. Spreading outward from the central brain are 8 separate mini-brains, technically called ganglia, one located in each arm. These ganglia aren't just passive relay stations, they are densely packed with neurons, around 40 million in each arm, and therefore capable of processing information independently from the central brain. To put that into perspective, each arm has roughly the same number of neurons as the brain of a frog. That's not just impressive, it's almost unheard of in the animal kingdom. Altogether, the octopus has around 100 million neurons, a staggering number for an invertebrate. But here's what's truly fascinating. More than 2/3 of those neurons aren't in the central brain at all. They're in the arms. This makes the octopus's nervous system decentralized, meaning control isn't concentrated in one place. Instead, each arm is like a semi-autonomous agent, capable of sensing, moving, and even learning on its own. Imagine you're an octopus resting on the ocean floor. A crab scuttles by and one of your arms, let's say your 3rd arm on the right, reaches out, tastes the crab with its suckers, and begins to react. That arm doesn't need to send a signal all the way to your head and back to decide what to do. It can begin to respond immediately, curling, grabbing, adjusting pressure, all without central oversight. In many cases, your central brain may not even be fully aware of what the arm is doing in the moment. This gives the octopus an incredible advantage. It allows for fluid, responsive movement in complex and unpredictable environments. Each arm is not just a limb, it's a thinking tool. It explores, experiments, adapts. It's like having 8 curious minds, all working in harmony with the central brain to solve problems in real time. What's even more astounding is that researchers have observed octopus arms cooperating without explicit direction. In one experiment, an octopus was given a challenging puzzle: a container with a twist-top lid holding a piece of food inside. Instead of one arm doing all the work, multiple arms coordinated, some holding the base, others twisting the lid, in a kind of elegant, unspoken dance. There was no visible hesitation, no apparent planning. Each arm seemed to know its role. And yet, when scientists examined brain activity, much of the work wasn't happening in the central brain at all. This led to a provocative idea that each arm of the octopus has its own kind of awareness. Not consciousness, perhaps, at least not in the human sense, but a functional intelligence. An ability to act, react, and learn locally. Some scientists have even proposed that the arms might possess their own body memories, remembering certain motions or actions that the central brain doesn't retain. This decentralized intelligence also means that an octopus can multitask in extraordinary ways. It can use one arm to explore a cave, another to dig in the sand, another to feel the texture of a rock, and still others to anchor itself or distract a predator, all simultaneously. Each arm gathers information, responds to stimuli, and contributes to the whole picture. It's as if the octopus is experiencing the world through 8 separate but cooperative viewpoints. There's also a dark, almost eerie aspect to this independence. If an octopus loses an arm, say in a fight with a predator, the severed limb can continue moving for several minutes. It will reach, contract, and respond to touch, as though still alive. That's because the arm's ganglion continues to process information, even after being separated from the central nervous system, though the octopus feels pain and stress from such an injury. The arm itself behaves like a ghost of the whole, still acting with purpose even in isolation. And yet, for all this distributed intelligence, the octopus remains a unified creature. Its central brain plays a crucial role in overseeing the overall behavior of the body. It's the seat of memory, of decision-making, of personality. It's where the octopus learns from experience and adapts its strategies. But the central brain doesn't micromanage. It trusts the arms to handle their own business. This kind of trust in the body, this delegation of awareness, is rare. In humans, most motor control is governed from the brain and spinal cord. But in the octopus, the body is its own thinker. The central brain isn't a dictator, it's a collaborator. Some scientists believe this may offer clues not just about octopuses, but about intelligence itself. Perhaps they say intelligence doesn't need to be centralized. Perhaps thinking can happen in networks, in parts, even in muscles. Perhaps consciousness, or something like it, doesn't always need a head to call home. The octopus, with its 9 brains, forces us to reconsider what it means to think, to decide and to feel. It blurs the boundary between brain and body, between control and autonomy. It shows us that intelligence can wear many shapes, and sometimes those shapes reach and twist and curl in the dark like arms exploring the mysteries of the sea. Why does the octopus need so many brains? Why not just rely on one central brain like most other animals? The answer lies in the life the octopus leads, a life of complexity, danger, opportunity, and constant adaptation. In the ever-shifting world beneath the waves, where light flickers and shadows deceive, the octopus must be ready to respond at every moment, in every direction, and often with more limbs than the central brain could possibly manage on its own. To understand why evolution gifted the octopus with this remarkable system, we must imagine life in 3 dimensions. Not just walking forward and backward as humans do, but floating, squeezing, climbing, jetting, crawling, and camouflaging in every direction, all at once. The octopus is a creature without bones, without a rigid frame, and with 8 endlessly flexible arms. It doesn't move like a fish or a crab. Its body flows, adapts, and transforms as needed. Such a body demands not only coordination but autonomy, the ability for each part to make decisions in real time, without waiting for approval from a central command. Imagine for a moment what it would be like to have 8 arms, each capable of acting independently. If your main brain had to consciously control every movement, every sucker grip, every joint angle, every twist and curl, you'd be overwhelmed in an instant. There simply isn't enough time for signals to travel back and forth across all those limbs in the heat of the moment. By the time the central brain processed what one arm was feeling, the opportunity to react might already be lost. This is where the magic of the octopus's distributed nervous system comes in. By placing a cluster of neurons, a mini brain, directly inside each arm, evolution gave the octopus the gift of immediacy. Each arm can react in milliseconds, responding to local sensations and stimuli, without having to ask the central brain for instructions. If the arm brushes against something rough, or if it detects a chemical trace of prey through one of its suckers, it can begin to act on that information instantly. It doesn't need to wait, it just knows. This design offers enormous survival advantages. When an octopus is hunting, it often extends its arms into tiny crevices, feeling around in the dark for crabs or shrimp. The central brain can't see what's inside those holes, but the arm can. It senses texture, shape and movement. And if it finds something, even if it's just a flicker of motion, the arm can seize, manipulate and retrieve it almost automatically, while the rest of the octopus remains focused elsewhere. It's like sending 8 scouts into the world, each with its own instincts and tools, working together without needing to report back for every little decision. But the benefit isn't just reaction time. The octopus's arm brains allow it to multitask on an incredible scale. One arm might be busy pulling apart a mollusk shell, while another explores a new hiding spot, and another prepares to anchor the octopus in place by gripping a rock. Meanwhile, the central brain can focus on larger decisions, watching for predators, planning escape routes, deciding where to go next. It's a division of labour unlike anything seen in vertebrates. Each part of the body becomes an intelligent participant in the animal's life, not just an obedient servant of the brain. This autonomy has led scientists to describe octopus arms as semi-independent agents, and in many ways they really do seem to operate with a will of their own. In experiments, detached octopus arms, which continue moving for a time after removal, have been observed avoiding unpleasant textures or curling protectively around themselves. These are not just spasms, they're organised behaviours, movements with purpose even when cut off from the main brain. Some researchers have even proposed that octopus arms might contain primitive forms of memory. Not memory in the human sense, no childhood stories or long-lost faces, but functional memory. An ability to remember successful patterns of movement, useful shapes, or learned behaviours. For example, an arm might recall how to open a shell after doing it several times, and perform the action more efficiently the next time, even if the central brain is distracted. So why so many brains? Because for the octopus, being flexible is more than physical, it's neurological. Its entire survival strategy depends on adaptability. One moment it's a predator, slipping silently through the reef. The next, it's prey, vanishing behind a cloud of ink. Then it's camouflage, a living stone. Then it's an escape artist slipping through a hole the size of a coin. Every transformation, every movement, every split-second decision relies on an intelligence that is spread out, like a net cast wide across its body. This decentralized structure also fits the octopus's life cycle. Most octopuses are solitary and short-lived. They don't learn from others. They don't have parents to teach them. Everything they know they figure out on their own. From the moment they hatch, they must explore the world and understand it quickly. Having multiple processing centers may allow them to absorb and respond to information faster, to experiment with their environment in many ways at once. And yet, despite this division, the octopus remains a whole creature. Its arms don't compete, they cooperate. Somehow the central brain and the arm brains maintain a fluid balance, a harmony of intention. There's no visible conflict, no confusion of purpose. It's as if each part knows how to dance with the others, improvising together in the liquid ballet of survival. For humans, this challenges our assumptions. We like to think of intelligence as centralized, a single mind directing a single body. But the octopus shows us that nature can take a different path, that sometimes thinking is better done in pieces, that flexibility, adaptability, and awareness don't need to be locked inside one skull. They can be shared, distributed, and expressed through movement itself. In the end, the question isn't just why the octopus has so many brains. It's what that teaches us about evolution, about intelligence, about the mind-body connection, and perhaps about letting go of control, trusting the parts of ourselves or our world that can act wisely even when we're not watching. To think without thinking, it sounds like a paradox, a contradiction, a puzzle wrapped in mystery. But in the strange and graceful world of the octopus, it's not just possible, it's the way life unfolds, moment by moment, arm by arm, ripple by ripple through the sea. Unlike us, the octopus does not need to consciously instruct every movement, every interaction, every subtle shift of skin or sucker. Much of what it knows without effort. Much of what it decides without awareness. This is the quiet magic of distributed intelligence, and it offers a vision of consciousness unlike any we are used to. In humans, we associate thinking with deliberate effort. We pause, we weigh options, we reflect, we analyze. Our brains work like centralized command centers, taking in information, processing it, and sending instructions to the body. But the octopus lives by a different rhythm. Its body is not controlled by a single will, but is a network of semi-independent parts, arms that move with purpose, respond to touch, and explore the world as if they are thinking for themselves. This way of being allows the octopus to move with extraordinary grace and complexity. Picture an octopus flowing over the ocean floor. One arm is reaching into a crevice, two others are anchoring to rocks, another is gently fanning the sand for hidden prey. None of this requires a conscious plan. The central brain might not be keeping track of every movement. The arms feel, sense, and act, as if each one carries a piece of the mind. In fact, experiments have shown that an octopus can continue solving physical tasks even when its central brain is chemically blocked or distracted. The arms continue their search, they're grasping, they're learning. They continue thinking without thinking in the way we understand it. This is not robotic motion, like the twitch of a severed limb. This is decision-making, action, intention expressed through flesh. What's more, the octopus doesn't have a map of its own body like we do. It doesn't visualize where each arm is in space. It doesn't even need to. Each arm is constantly gathering sensory information, taste, touch, tension, texture, and feeding it back into its own local nervous system. This allows it to move with confidence, precision, and flexibility, even in environments it can't fully see. Imagine trying to thread 8 long, flexible, boneless arms through a maze of rocks, coral, and currents, all while camouflaging your skin, monitoring for predators, and searching for dinner. To do this with just one central brain would be too slow, but when each arm is allowed to think for itself, the octopus becomes a master of the unknown. It adapts in real time. It makes sense of the world not from above, but from within. This decentralized processing might seem chaotic, but in the octopus it creates harmony. There is no conflict between the arms, no need for perfect coordination from a central source. Like the musicians in a jazz ensemble, each arm listens, responds, and improvises in sync with the others. They are not waiting for instructions, they are simply playing, guided by sensation, curiosity, and instinct. In many ways, this style of intelligence is embodied. That is, it arises from the body itself, rather than being imposed upon it. For the octopus, the body is not separate from the mind. The body is the mind. Thought is not confined to the brain, but is woven into muscle and nerve, into the very texture of being. This idea is beginning to influence how some scientists understand cognition, not as a purely cerebral process, but as something that can emerge from movement, sensation, and physical experience. And perhaps this is what makes the octopus so captivating. It shows us a different kind of intelligence, one that doesn't need words or symbols, one that doesn't sit behind the eyes like a little pilot in the skull. The octopus feels its way through life. It learns by touching, tasting, sensing, and reacting. It doesn't have to think about what it's doing, just does it, and in doing so it knows. There is something beautiful and even meditative about this. We, as humans, often become trapped in our thoughts, over-analysing, over-planning, overthinking. But the octopus reminds us that not all thinking is conscious. Not all awareness requires reflection. Sometimes wisdom flows from the body, from instinct, from quiet observation. When an octopus moves through the water, it does not hesitate. It does not ask itself which arm should go where, or whether it made the right choice. It simply moves, effortlessly, fluidly. Each arm becomes an extension of the world around it, responding in kind, adapting, adjusting, flowing. To think without thinking is not to be thoughtless, always. It is to be in tune. To be so deeply connected to the environment, so attuned to sensation that decisions arise naturally. That movement is its own form of knowing. This might sound almost spiritual, and in a way it is. The octopus shows us that there is more than one way to be aware, more than one way to be intelligent. Its mind is not trapped in its head. Its mind extends through every arm, every sucker, every motion. And so when you watch an octopus drifting over the reef, arms curling and uncurling like seaweed in a current, you are witnessing a kind of silent thinking, a dance of awareness without words, a symphony of sensation without self-reflection, a creature that lives not in thought, but through it, not in planning, but in pure presence. The octopus doesn't need to stop and wonder what to do next. It is already doing it. This is the heart of its brilliance, the ability to think without thinking, and in doing so to survive, adapt and thrive in one of the most unpredictable environments on Earth. The octopus doesn't just explore the world with sight or sound. It explores with touch, with taste, and with sensation so detailed, so intimate, that every movement becomes an act of discovery. Each of its arms is lined with suckers, round, soft, muscular discs that do far more than just grip. These suckers are sensory miracles. With over 2,000 of them on its body, sometimes up to 250 per arm, the octopus uses them to feel the ocean in a way that no human ever could. But what's even more remarkable is that the octopus doesn't just feel with its suckers, it tastes and smells with them too. To the octopus, touch is more than contact, it is knowledge. Each sucker contains thousands of chemical receptors and mechanical sensors. When a sucker makes contact with a surface, it isn't just detecting texture, it's chemically analysing what it touches. It's asking, is this food? Is this friend? Is this foe? Long before the octopus sees a creature with its eyes, it may already know its identity through the rich world of information collected by its arms. This extraordinary sensitivity allows the octopus to create a mental map of its environment using its arms alone. As it glides across the rocky seafloor or explores the tangled world of coral and crevices, its arms reach forward, out to the sides, backward. Each sucker gathering details, each neuron processing microtextures and molecular cues. The octopus doesn't need to see a shrimp hiding in a crack. It can feel the shape, taste the proteins, and identify its presence long before any visible clue appears. This ability is called chemoreception, the detection of chemical compounds through physical contact. In humans, our taste and smell are separate senses located in our mouths and noses. But in the octopus, these senses are externalized. Every arm is a tasting, smelling limb, sampling the ocean with every motion. When a sucker touches a rock, it doesn't just register smooth or rough, it detects the faint residue of life, the biological signatures left behind by fish, algae, or prey. It's as if the arm is licking the world with every brush and grip. This means the octopus lives in a completely different kind of sensory reality. Imagine walking into a room and instantly knowing who's been there recently, what they touched, and whether they were safe or dangerous, all by grazing your fingers across a surface. That's the octopus's world. Every movement, every contact, every slight curl of an arm is an act of deep sensing. And yet, to the octopus, this is not extraordinary. This is simply how it exists, fully, constantly, sensually immersed in its surroundings. What's more, the arms don't wait for the brain's permission to begin exploring. They reach, they taste, they decide, each on their own. A sucker might encounter a new texture and pass that information immediately to its local ganglion, which determines how to react. Should it release and retreat? Should it tighten its grip? Should it signal the rest of the arm to investigate further? These decisions happen in milliseconds, often without the central brain's involvement. The octopus is not commanding each arm like a puppeteer. Instead, it trusts each limb to gather, interpret, and act upon its own sensory information. This trust in the arms, this delegation of awareness, is one of the reasons the octopus moves with such ease and fluidity. It doesn't second-guess its choices. It doesn't need to oversee each interaction. The suckers explore freely, acting like thousands of tiny minds, each contributing to the octopus's understanding of the world, and together they form a chorus of sensation, a constant flowing stream of feedback that keeps the octopus alert, informed, and adaptive. Scientists studying this system have found that suckers are capable of discerning incredibly subtle differences between surfaces, even those indistinguishable to human fingers. They can detect the chemical composition of surfaces, the presence of microscopic organisms, and even whether something has recently been alive. This helps the octopus determine whether a surface is edible, safe, dangerous, or interesting. It allows them to find prey that hides not in the open, but deep within the nooks and crannies of the ocean floor. But suckers do more than just detect, they also remember. While the octopus doesn't have long-term memory in each arm, it can learn short-term patterns. If a sucker is burned or touched with something unpleasant, it will be more cautious the next time. If it finds something rewarding, like food, it will respond more quickly the next time it encounters a similar cue. This means the suckers are not just passive sensors, they are dynamic learners. Touch also plays a critical role in the octopus's social and emotional behavior. Though octopuses are mostly solitary, they still experience moments of interaction. In rare cases, octopuses in captivity have been observed gently touching their caretakers with their suckers, not in aggression, but in curiosity. These touches are deliberate, slow, and focused. They are, in a way, the octopus's version of eye contact, its way of saying, "Who are you? What are you made of?" And if an octopus trusts you enough to allow its suckers to explore your skin, it is offering a kind of sensory intimacy. It is tasting your presence, feeling your warmth, analysing your identity. In those moments, there's a strange connection, not through speech or gaze, but through the gentle pull of suckers wrapping softly around a hand, asking questions in a language of touch that we can barely comprehend. The octopus's world is built from these questions. It is not a loud world, not one of roaring senses or blinding lights. It is a subtle world where information flows through thousands of tiny, curious mouths on the ends of flexible arms. It is a world where touch is truth, where texture tells stories, and where every surface whispers secrets, if you know how to listen with your skin. So when you see an octopus moving across the reef, its arms exploring every crevice, each sucker gently pressing, releasing, pressing again, you're watching a mind at work, a mind not trapped in a skull but diffused through its body, a mind that feels first, then understands, a mind that knows the world not by looking at it, but by touching it, by tasting it, by becoming one with it. One of the most astonishing revelations about octopuses is not just their intelligence in the wild, but how vividly that intelligence emerges in captivity, particularly through their ability to solve problems, manipulate objects, and learn through observation. These are not behaviours we expect from mollusks, creatures whose cousins include clams and snails, but time and time again the octopus defies expectations. In laboratory settings and aquariums around the world, octopuses have astounded scientists and caretakers alike with their cleverness, creativity, and sometimes mischievous behaviour. Perhaps the most famous demonstration of their mental agility is their ability to solve puzzles. These aren't just simple tasks like finding food in a hidden corner. Octopuses have been shown to open jars with screw-top lids, remove stoppers from tubes, navigate mazes, and even choose between objects based on visual cues. What's striking is not only that they can do these things, but how quickly they learn. In one experiment, an octopus was given a clear jar with a tasty crab inside. The lid had to be twisted off to access the meal. After some initial trial and error, the octopus figured out how to grasp the jar with several arms, hold it steady, and rotate the lid using another arm. Once it succeeded, it remembered the technique. The next time it did it faster. This ability to learn and retain new information is a hallmark of higher intelligence. In vertebrates, we associate this kind of behaviour with mammals like dolphins, primates and dogs, but in the octopus, it comes from an entirely different evolutionary path. With no shared ancestors that possessed a brain, the octopus and humans developed complex cognition independently. This makes their intelligence not only impressive, but deeply alien. It doesn't mirror our own. It evolved in the shadows of the deep sea, guided by entirely different pressures and possibilities. Beyond puzzles, octopuses demonstrate a surprising ability to interact with their environment in playful ways. In some aquariums, caretakers noticed octopuses playing with objects, shooting jets of water at floating toys or repeatedly pushing items into water currents only to chase them down again. Play is often considered a sign of intelligence because it suggests an animal is engaging with its surroundings, not out of necessity but out of curiosity and interest. For the octopus, play may also serve as a kind of experimentation, testing how objects respond, learning cause and effect, or simply exploring what its body can do. And then there's the octopus's relationship with its environment. It's not content to simply inhabit its tank or den, it often modifies it. In the wild, octopuses are known to collect shells and stones, arranging them around their dens as barriers or camouflage. In captivity, they sometimes rearrange objects in their tanks, cover or uncover openings, or bury items they don't like. This kind of environmental manipulation indicates not only awareness, but also a kind of personal preference. Some octopuses have been observed moving rocks over drain holes. They find annoying or aiming water jets at lights or equipment that disrupt their peace. In some of the more playful or perhaps rebellious cases, octopuses have even demonstrated what can only be described as prank-like behaviour. At one research facility, staff kept finding unexplained puddles of water near the floor each morning. Security cameras revealed that a resident octopus had learned how to shoot a precise jet of water at a small light fixture that it disliked. The stream shorted out the light and caused it to leak water. It was not a fluke. It happened repeatedly, always at night, and always with apparent purpose. In another story from a public aquarium, fish in a neighbouring tank were mysteriously disappearing overnight. For weeks, staff were baffled, until they discovered that an octopus in a nearby tank had figured out how to lift its lid, slither out, crawl across the floor, climb into the other tank, eat a fish, and return home before dawn. The escape routes, the return journey, the timing, it was all executed with stealth and skill. These behaviours aren't just clever, they imply foresight, memory, and problem-solving, abilities once thought to be exclusive to vertebrates. Scientists have also tested octopus learning through visual discrimination tasks. In one experiment, octopuses were shown different shapes and trained to associate one shape with a food reward. Over time, they learned to select the correct shape consistently. In some studies, they even remembered the choice several days later. What's even more intriguing is that some octopuses seem to recognize individual people, responding differently to familiar versus unfamiliar humans, showing excitement or caution depending on who approached their tank. All of this suggests a mind that is not only sharp but flexible, a mind capable of adapting, of learning from experience, and of applying that knowledge to new situations. The octopus doesn't simply follow instinctive rules. It experiments, adjusts, and changes its approach. In scientific terms, this is called cognitive flexibility, and it's one of the clearest signs of higher-order thinking. This kind of learning is especially impressive because the octopus doesn't have a long life in which to accumulate experience. Most species live just 1 to 2 years, and yet in that short time they show evidence of rapid learning, memory retention, and behavioural experimentation. It's as though their brains are tuned for speed, evolving not for endurance but for a brief intense burst of learning and living. And remember, much of this learning takes place through the arms. With more neurons in their limbs than in their central brain, octopuses are literally thinking with their arms, sensing, reacting, and adapting in real time. When an octopus reaches into a tube or feels around a box, its arms aren't just responding blindly. They're processing information, testing strategies, and updating their understanding of the object. This raises a profound question. How much of the octopus's learning is even conscious in the way we think of consciousness? Does it reflect and plan? Or does its intelligence emerge more fluidly, more instinctively, embedded in sensation and movement, not thought? Perhaps for the octopus, thinking is not something that happens before action. It is the action itself. Touching, grasping, tasting, manipulating. These are its thoughts unfolding through motion. In this way, the octopus reveals a deeper truth about intelligence, that it can look many different ways, that it doesn't always require words or tools or long lives, that sometimes intelligence is quiet, it hides beneath the surface, it moves without a sound. And in a creature with no bones, no voice, and no social circle, it expresses itself in the curl of an arm, the turn of a jar lid, the playful toss of a shell. To watch an octopus solve a puzzle is to witness something deeply mysterious, a mind that evolved in darkness, in silence, under pressure, a mind not like ours, and yet undeniably bright. In the end, the octopus doesn't just solve problems, it becomes the solution. One sucker, one arm, one curious motion at a time. The nervous system of the octopus is one of the most unusual and complex in the animal kingdom, so much so that scientists are still unravelling its mysteries. At first glance, it seems like a contradiction. How can a creature without a backbone, without any internal skeleton at all, possess such a sophisticated network of neurons, so vast that it rivals the brains of some mammals? And how can that intelligence be spread across its body in such a way that the very concept of where the mind is becomes difficult to define? To begin to understand this, let's look at the numbers. The octopus has approximately 100 million neurons, a staggering figure for an invertebrate. To compare, that's more than a rat, more than a frog and nearly as many as a dog. But unlike in mammals, where the vast majority of those neurons are concentrated in the brain and spinal cord, the octopus distributes its neurons throughout its body in a radically different way. In fact, more than 2/3 of its neurons are located in its arms, not in its central brain. This decentralized arrangement creates a nervous system that functions more like a network than a command center. There is a brain in the octopus's head, oval-shaped, nestled between its eyes, but this brain doesn't control every action. It doesn't issue commands like a general. Instead, it collaborates with the arm ganglia, clusters of neurons in each limb that process information locally and can even act independently. These arm ganglia are so complex that each arm can, in some situations, behave as though it has its own miniature brain. In practical terms, this means that if an octopus is exploring a coral crevice with one of its arms, the arm itself is capable of reacting to stimuli without first sending messages all the way back to the main brain. It doesn't need to ask permission to recoil from danger, to grab a passing shrimp, or to continue reaching deeper into the darkness. The neurons in the arm can detect chemicals, analyze textures, and control the suckers, all in real time. This dramatically speeds up response times and allows for incredible flexibility both literally and cognitively. Even more astonishing is the structure of the octopus's nerve fibers. In humans and many other animals, nerves transmit information using a combination of electrical signals and the chemical synapses. But in the octopus, some of these connections are faster and more efficient than what we see in vertebrates. Some researchers have even proposed that the octopus's neural wiring is organized to prioritize parallel processing, allowing it to manage multiple streams of sensory input and motor output simultaneously. This helps explain how the octopus can perform such astonishingly complex tasks with such apparent ease. Imagine reaching out with your hand to open a jar while balancing on one foot and keeping your eyes on a distant object. Now imagine doing that with 8 arms, all moving independently, all engaging with the environment in different ways, and doing it underwater, without bones, in a constantly shifting 3-dimensional space. The octopus does this every day. It navigates reefs, evades predators, hunts, builds dens, and camouflages itself in fractions of a second, all thanks to the fluid, distributed intelligence of its nervous system. What's even more fascinating is how this system communicates within itself. Although each arm can operate semi-independently, there are still neural pathways connecting the arms to the central brain. But instead of issuing step-by-step instructions, the brain sends high-level directives, general goals rather than micromanaged orders. The brain might say, "Search this area," and the arms will interpret and execute that command in their own unique ways. Each arm may try a different approach, one exploring a hole, another feeling along a surface, another staying alert for danger. This autonomy also creates the potential for arms to behave differently depending on context. If an arm encounters something painful or threatening, it can react immediately, without waiting for the central brain to evaluate the danger. In one famous experiment, severed octopus arms, separated entirely from the rest of the body, still reacted to stimuli for several minutes. They recoiled from their unpleasant textures and even tried to grasp objects as if they were still part of a living animal. This reveals just how embedded the neural control is in each arm, how much of the octopus's self is distributed across its body. And yet, for all this independence, the octopus still acts as a unified creature. Its central brain integrates information, makes broader decisions, and remembers past experiences. It is the source of learning, of strategic behavior, and of long-term adaptation. The brain remembers which actions led to success or failure. It adjusts tactics over time. It shapes personality. Because yes, octopuses have personalities. Some are shy, some bold. Some are cautious problem solvers, while others are quick and aggressive. And just like in humans, these traits emerge not just from instinct, but from how the nervous system develops and responds to life's challenges. The connection between the central brain and the arm ganglia may even function somewhat like a dialogue. While the arms can act on their own, they also feed information back to the central brain. This allows the brain to build a richer picture of the environment, to learn what each arm discovers, and to adjust the octopus's overall behavior accordingly. It's not a top-down system, it's a conversation constantly flowing through a web of neurons spread across the body. This design is especially well suited to the octopus's lifestyle. Unlike many animals, octopuses are solitary, short-lived, and live in environments filled with complexity and danger. They must learn quickly, solve problems on their own, and react to changing circumstances with creativity and speed. A rigid centralized nervous system wouldn't be flexible enough, but the octopus, with its fluid nervous network, can adapt moment by moment, thinking with its arms, reacting with its skin, and learning with its entire body. In some ways, this system is more similar to artificial intelligence than to typical biological models. It behaves like a distributed computing network, where multiple nodes process data locally, but also share it with a central system. The octopus doesn't know what it's doing, in the same way we might describe human awareness, but it exhibits all the signs of sophisticated cognition, memory, learning, problem-solving, and adaptability. Ultimately, the octopus nervous system challenges our ideas about what a brain is supposed to look like and what a mind is supposed to be. It shows us that intelligence isn't limited to one design. It can be centralized or spread out. It can sit quietly in a skull or flow through arms that taste, touch, and decide. It reminds us that there are many ways to be aware, many ways to understand, and many ways for life to express brilliance. In the octopus, we see not just a marvel of evolution, but a living question, a creature that forces us to rethink the very nature of thinking itself. The octopus is not only a master of intelligence, it is also a master of disguise. Few creatures in the natural world possess the ability to transform themselves so completely, so convincingly, and so swiftly as the octopus does. It can shift its appearance in the blink of an eye, changing not only its color but also its texture, pattern, and posture. In doing so, it becomes nearly invisible, blending into coral, sand, rock, or seaweed with a precision that defies belief. This transformation is not just for beauty or theatrics. It is a survival tool, a hunting tactic, and a form of communication all wrapped into one. And at the heart of this ability lies a deeply intricate and astonishingly responsive nervous system, one that extends beyond the brain and into the very skin of the animal. The skin of the octopus is alive with sensors and control systems that are directly influenced by its nervous system. It is not a passive covering, but an active canvas that responds instantly to the environment. This skin contains specialized cells called chromatophores, which are tiny sacs filled with pigment. Each chromatophore can expand or contract to reveal or conceal its color, much like opening or closing an umbrella. When many chromatophores are activated at once, the skin can change color with dazzling speed and precision. But that's only the first layer. Beneath the chromatophores lie iridophores and leucophores, cells that reflect and scatter light, creating shimmering effects, metallic sheens, and background matching under various lighting conditions. Together, these layers allow the octopus not just to imitate the color of its surroundings, but to manipulate light itself, becoming brighter or darker, rough or smooth, conspicuous or invisible depending on its needs. Unlike chameleons, whose color changes are relatively slow and chemically driven, the octopus's camouflage is neurologically controlled. It happens in real time, powered by the same distributed network of neurons that gives the octopus its remarkable intelligence. Signals from the brain, and possibly from the arm ganglia, travel instantly to the skin, triggering minute adjustments across millions of chromatophores. These signals are based not only on what the octopus sees, but what it feels. Since its eyes are positioned on either side of its head, the octopus gathers a wide field of vision, and its arms provide sensory feedback from below and behind. The result is a 360-degree awareness of the environment, allowing it to match its surroundings from all angles. Even more astonishing is that this camouflage system works in a creature that is likely colorblind. Despite lacking color vision as we understand it, the octopus can mimic colors with extraordinary accuracy. Scientists still don't fully understand how this is possible. One hypothesis suggests that octopuses might detect color through their skin itself, using light-sensitive proteins called opsins that are embedded not only in their eyes but also in their dermis. If this is true, it would mean that the octopus literally sees with its skin, sensing light and color directly through its body and using that information to inform its disguise. The ability to camouflage so effectively serves many functions. First and foremost, it is a defense mechanism. The ocean is full of predators, sharks, eels, larger fish, and the octopus, with its soft boneless body, has little natural armor. But by blending into its surroundings, it becomes invisible, able to vanish into a coral reef or flatten itself against a rock. It can even imitate the texture of its hiding place using tiny muscles in its skin to create ridges, bumps, or smooth patches that match the feel of its environment. This textural change is controlled through structures called papillae, muscular projections that can be raised or lowered in response to signals from the brain. Papillae give the octopus the power not only to look like a piece of coral or a rock, but to feel like one too. The octopus doesn't just hide, it becomes its hiding place. But camouflage isn't just for hiding, it's also for hunting. An octopus can change its colour and texture to sneak up on prey undetected. It might adopt the look of a harmless clump of seaweed, drifting lazily with the current, before lunging forward to strike. Or it may become a patch of algae near a rocky crevice, waiting patiently for a crab to wander too close. Camouflage turns the octopus into a living trap, perfectly still and perfectly poised. In addition to these uses, octopuses sometimes use their skin to communicate. Though they are largely solitary animals, octopuses have been observed flashing sudden changes in colour to signal aggression, readiness to mate, or warnings to potential threats. A bright white display may warn another octopus to stay away. A rippling wave of colour might signal curiosity or arousal. In some species, males display distinct colour patterns to court females or to intimidate rival suitors. These visual signals are part of a silent language, a language spoken entirely through the skin. Some of the most astonishing examples of octopus disguise are cases of mimicry. The mimic octopus, found in Southeast Asia, takes camouflage to a new level by impersonating not just the environment but other animals. It can flatten its body and swim like a flounder, raise its arms to resemble a lionfish's spines, or arrange its limbs to look like the tentacles of a venomous sea snake. These impersonations are so convincing that predators are often fooled, choosing to keep their distance rather than risk an encounter with what they think is a dangerous creature. This mimicry is not instinctive in the way we often think of animal behaviour. The octopus chooses how to disguise itself based on the situation. It learns from experience, adapts its techniques, and selects the best disguise for the moment. This is contextual intelligence, applied not with words or thoughts, but through shape, movement, and colour. Perhaps what makes the octopus's disguise so enchanting is the way it merges body and mind. Its transformations are not clunky or forced. They are fluid, seamless, and graceful. There is no delay, no obvious effort. The octopus simply becomes what it needs to be. One moment a boulder, the next a patch of seaweed, the next a ghost slipping through the water. This shape-shifting ability challenges how we think about identity. We tend to believe that we are defined by how we look, that our outward appearance is part of who we are. But for the octopus, identity is a choice. It is changeable. It is strategic. The octopus reminds us that survival, awareness, and expression can come not from being one thing, but from becoming many things. It is a lesson not just in biology, but in the beauty of adaptation. In a world that is always shifting, always testing, the octopus thrives by staying fluid, responsive, and awake to its surroundings. It teaches us that intelligence is not only found in the brain, but in the skin, in the muscles, in the silent dialogue between body and world. So the next time you see an octopus vanish before your eyes, remember, it hasn't disappeared. It has transformed, it has read the room, analysed the light, assessed the texture, and rewritten itself, silently, instantly, and brilliantly. It is thinking not with thought, but with being. And in that act of disguise, it becomes something more than animal. It becomes art. Among the many mysteries of the octopus, perhaps none is as eerie, as fascinating, or as unsettling as the autonomy of its arms, even when they are no longer attached to its body. In most animals, the loss of a limb brings an end to its movement. A severed leg twitches briefly, then stops. But with the octopus, a detached arm can continue to move, explore, grasp, and even attempt to feed, as though it still remembers its purpose. It's not merely a reflex, it's something far more sophisticated, and it reveals the strange independence of the octopus's nervous system in a way that defies our usual understanding of what it means to be alive, to be whole, and to be aware. When an octopus loses an arm, whether due to injury, predation, or self-amputation, a process called autotomy, that arm can remain active for up to an hour. It will reach out, respond to touch, recoil from painful stimuli, and even grasp objects as though still connected to the central brain. At first, this might seem like a simple case of leftover nerve activity, like the way a decapitated chicken can continue running for a short time. But in the octopus, the behaviour is far more complex. The arm doesn't just twitch, it behaves. It interacts with its environment in ways that suggest some level of processing, some kind of decision-making, even in the absence of the brain. This bizarre phenomenon is possible because of the way the octopus's nervous system is designed. Each of its 8 arms contains a large ganglion, a cluster of neurons that functions almost like a small brain. These ganglia don't simply relay signals to and from the central brain. They are capable of local control, interpreting sensory information, initiating movement, and executing coordinated actions entirely on their own. When the arm is intact and attached, these actions are typically in sync with the octopus's goals and behaviours. But when the arm is severed, the ganglion continues to function for a time, isolated but still responsive. This level of autonomy is rare in the animal kingdom. In humans, for instance, all meaningful movement requires coordination from the central nervous system. Severed limbs might spasm, but they cannot respond intelligently to the world around them. In the octopus, however, the arms are decentralized processors, able to perform complex tasks with or without the brain's help. This independence likely evolved as a survival advantage, allowing the octopus to multitask, respond to threats with speed, and explore its environment from multiple points at once. Experiments have shown just how complex this limb autonomy can be. In one study, researchers placed pieces of food near a severed octopus arm. Remarkably, the arm reached for the food, grabbed it, and tried to move it toward the spot where the mouth would have been if the arm was still attached to the body. This suggests that not only does the arm retain motor memory, it retains an internal model of the body's layout, of where things used to be. It behaves as if the rest of the octopus is still there. The arm is acting out a story that no longer has an ending, following the traces of a neural pattern imprinted deep in its circuitry. Even more unsettling is the fact that these arms can respond appropriately to different stimuli. They recoil from irritants. They avoid uncomfortable textures. They differentiate between touch and pressure. The suckers still taste and feel. The muscles still contract with purpose. The severed arm is, for a time, a kind of ghost, an echo of the octopus's mind acting with purpose but without a master. This kind of behaviour forces scientists to ask strange questions. What is control? What is awareness? Where exactly is the self in a creature like the octopus? If each arm can behave independently, then is the octopus truly one being? Or is it a colony, a federation of semi-autonomous parts working in harmony under a central coordinator? The answer might be somewhere in between. The octopus is still a unified animal. Its central brain learns, remembers, chooses goals, and makes high-level decisions, but the brain delegates. It sends out general instructions like, explore this area or search for food, and the arms interpret and execute those goals in their own ways. They are not drones, they are agents. The result is a form of intelligence that is distributed, collaborative, and beautifully efficient. This system also allows the octopus to survive severe injuries. If it loses an arm, it can still function. It can still hunt, defend itself, and escape. The lost limb will eventually regenerate, a remarkable feat in itself, but in the meantime the remaining arms can take on the extra work. They can compensate, adapt and reorganize without needing a new blueprint from the central brain. This kind of redundancy is a powerful evolutionary advantage, and it makes the octopus resilient in a dangerous world. From a philosophical perspective, the autonomy of the arms challenges our ideas about what it means to have a mind. Most animals, including humans, operate on a central model of control. One brain, one seat of awareness. But the octopus asks us to consider the possibility that thinking can be fragmented and still be functional. That intelligence can be broken into pieces, and those pieces can still act with purpose. It's a kind of modular consciousness, a mind made not of one voice, but of many. This distributed intelligence might seem alien to us, but in some ways it mirrors the way complex systems work in nature. Flocks of birds, schools of fish, swarms of bees, all exhibit collective intelligence without a central leader. The octopus is like a miniature version of this phenomenon, contained within a single creature. It is a symphony of minds, each arm a player improvising its part, coordinated by a central conductor who doesn't dictate every note. Even in mythology and folklore, the octopus has long been associated with mystery, with shape-shifting, with strange powers that lie just beneath the surface of understanding. Now, science confirms what stories have always hinted at, that the octopus is not just a creature of the sea, but a puzzle for the mind, a living paradox of unity and division, control and freedom, centrality and autonomy. So when you watch an octopus moving across the ocean floor, reaching with one arm while another anchors, while yet another probes a crack in the reef, you're seeing not just a body in motion, but a network of minds in perfect coordination. And if an arm were to be lost, by accident, by escape, by sacrifice, it would not simply fall silent. For a time it would remember, it would move, it would reach, it would try to continue its part in the dance, unaware that the music had ended. This haunting ability is a testament to the octopus's uniqueness, a creature whose body is as alive with thought as its brain, a creature that reminds us that intelligence can wear many shapes, and that sometimes awareness lingers, even when the body forgets. The octopus is often called the Houdini of the sea, and not without reason. With no bones, a body of shifting softness, and an intelligence that thrives in the shadows, the octopus has earned a reputation as an escape artist, a trickster, and a master of evasion. But behind these astonishing feats lies a deeper truth. The octopus is not simply trying to flee, It is constantly thinking, adapting, and outsmarting the many dangers it faces in the underwater world. To survive, it must be clever. To hunt, it must be subtle. And to outwit both prey and predator, it must sometimes deceive, distract, and disappear. Predators in the ocean are many and merciless. Sharks, moray eels, barracudas, and large fish all pose a constant threat to a soft-bodied animal like the octopus. Without scales, shells, or claws, it seems vulnerable, exposed. And yet the octopus doesn't rely on brute force or speed to escape. It uses something far more effective, deception. It bends the rules of visibility and expectation. It refuses to be predictable, and it often wins not by fighting, but by vanishing. One of the most dramatic examples of this is the octopus's use of ink. When startled, it can release a thick black cloud into the water, instantly obscuring its body from view. But this inky smoke screen is not just for hiding. Scientists believe it also contains substances that interfere with the predator's senses, a chemical distraction that may confuse smell and taste receptors, further disorienting the attacker. In some species, the octopus releases a pseudomorph, a shaped cloud of ink that mimics the outline of its body. While the predator lunges toward this phantom, the real octopus slips away unseen. But the ink is only the beginning. Long before it is forced to flee, the octopus often avoids detection altogether through camouflage and shapeshifting, becoming part of its surroundings. It doesn't just hide, it disguises itself so convincingly that predators pass by without the slightest suspicion. It may flatten itself against a rock and turn mottled brown, or bunch its arms like the fronds of seaweed swaying in the current. Some species imitate poisonous animals, like lionfish or sea snakes, adopting not only the colour but the motion patterns of these dangerous creatures. This behaviour is called Batesian mimicry, and it's a strategy that works. The predator sees danger and chooses another target. When the octopus does need to escape, it can do so in ways that seem like magic. It can fit through openings no larger than a coin, contorting its body to slip through cracks, pipes, and holes. Its only hard part is its beak, a parrot-like mouth located at the centre where all 8 arms meet. If the beak can fit, the entire octopus can follow. This makes it incredibly difficult to contain, which is why aquariums go to great lengths to secure their tanks. There are countless stories of octopuses escaping their enclosures, crawling across floors, and even entering other tanks to hunt fish. They move silently, quickly, and with intention, like thieves in the night, thinking every step through. But the octopus is not merely an escape artist, it is also a strategic thinker. When it hunts, it uses tactics that suggest patience, planning, and foresight. It will sometimes stalk a crab from behind, staying perfectly still until the moment is right, then strike with blinding speed. In other situations, it may use its arms to block off exits, surrounding the prey before moving in. Some octopuses have even been observed using tools, collecting coconut shells, for example, and hiding inside them like a hermit crab. Later, they carry the shells with them, assembling them as a mobile shelter when needed. This kind of behaviour suggests not only memory, but planning for the future, a rare trait among invertebrates. One remarkable story involves an octopus that was seen carrying 2 halves of a coconut shell across the seafloor. When it found a suitable spot, it arranged the shells, climbed inside, and closed them over itself. This was not random behaviour, it was deliberate, calculated, and effective. The octopus had learned that the shell provided protection, and it had planned ahead to bring that protection with it. This kind of strategic use of materials blurs the line between animal behaviour and what we typically call intelligence. The octopus's trickster nature also extends to its interactions with humans. In aquariums, they often become known for their personalities. Some are shy, others curious, and a few downright mischievous. There are stories of octopuses short-circuiting lights by squirting water at them, rearranging their tanks in defiance of their caretakers, or waiting for the perfect moment to slip out when no one is watching. One octopus was discovered sneaking out of its tank at night to feast on neighbouring fish, then returning before dawn, leaving the staff baffled by the missing animals. Only a nighttime camera revealed the clever culprit. These behaviours raise fascinating questions. Does the octopus understand cause and effect? Does it enjoy manipulating its environment, or even outwitting others? While we cannot know exactly what an octopus feels, we can see that it learns, remembers, and adapts, hallmarks of what we often call cleverness or cunning. In this sense, the octopus is not just a master of disguise and escape, it is a trickster in the deepest mythological sense. It bends reality, surprises observers, and refuses to be pinned down by expectations. In the myths of many cultures, trickster figures are liminal beings. They exist between categories, shifting shapes, crossing boundaries, breaking rules. The octopus fits this role perfectly. It is soft yet strong, solitary yet social, hidden yet present. It changes its identity, slips past obstacles, and teaches us that flexibility, both physical and mental, is sometimes the greatest power of all. Ultimately, the octopus survives not by dominating its world, but by understanding it deeply. It reads its surroundings, learns its patterns, and uses that knowledge to make itself invisible, unpredictable, and elusive. It doesn't need brute force. It has something better: ingenuity. To watch an octopus escape, to see it vanish in plain sight or wriggle through a hole no larger than its eye, is to witness something deeply humbling. It reminds us that intelligence isn't always loud. Sometimes it's silent, hidden, and soft. Sometimes the smartest creatures are those that leave no trace, that play with the rules rather than follow them. And sometimes the greatest trick is simply disappearing, like a shadow in the sea. Beneath the shifting light of the ocean's surface, where coral gardens bloom and seagrass sways in the current, the octopus begins its hunt. There is no fanfare, no sound, no stirring of the sea, only movement, slow, deliberate, and silent. The octopus does not chase. It does not announce itself. It creeps, it flows, it waits. As a predator, it is the embodiment of stillness and suddenness, an ambush artist whose strength lies in its patience and its ability to become the background. Hunting for the octopus is not a matter of brute force, but of strategy, stealth, and an extraordinary awareness of space. With no rigid skeleton to limit its motion, the octopus can extend and twist its arms into the narrowest cracks in the reef, curling them into holes too small for almost any other predator. Its suckers, thousands of them, taste and feel their way forward, searching for clues: an overturned pebble, the faint chemical trail of a crab, the scrape of shell against rock. Each arm operates semi-independently, probing, tasting, learning. This allows the octopus to hunt in multiple directions at once. One arm might be exploring a tunnel in the coral, another anchoring to a nearby rock, while others stay alert for threats or opportunities. It is not just looking for prey, it is feeling the entire three-dimensional world around it, mapping the space through direct contact, adjusting its movements on the fly. When it detects its target, a crab tucked into a crevice, a shrimp hidden under a ledge, the octopus doesn't strike immediately. It calculates. If the crab is in an open area, it might approach slowly, colour shifting to match the sand, flattening itself until it appears as nothing more than a passing shadow. If the crab is in a hiding place, the octopus may wrap its arms around the entrance, forming a living trap, and then pump water into the hole, flushing the crab out into its waiting grasp. Some octopuses have even been observed using debris or shells to block escape routes before initiating the attack, effectively setting a trap, an advanced hunting technique rarely seen in animals without backbones. Others will tap gently on a hiding place with a single arm, causing the prey to retreat, right into the reach of another arm lying in wait. These strategies are not random. They are selected from experience, learned through trial and error, and adjusted with precision. The moment of capture is sudden and decisive. The octopus strikes with astonishing speed, its arms wrapping around the prey, suckers locking on with vacuum-tight pressure. In an instant, the victim is immobilized. And if it struggles, the octopus can inject a paralyzing venom through its beak, a sharp curved mouth located at the center of its body. The venom contains enzymes that begin to break down the prey's tissues, turning it into a soft meal even before digestion begins. But the hunt is not over until the octopus has found a secure place to eat. Unlike some predators that feed in the open, the octopus is cautious. It carries its prey to a den or secluded spot, shielding itself from potential threats. Sometimes it will create a pile of discarded shells outside its den, a kind of telltale midden that reveals where it has been feeding. Inside, it works meticulously, using the beak to crack open hard shells, its suckers to hold the prey in place, and its salivary enzymes to extract every edible part. Even the choice of prey reflects the octopus's intelligence. It doesn't eat whatever it finds, it selects. Crabs are a favourite, nutritious and challenging, but it will also hunt clams, small fish, snails, and even other octopuses on occasion. Its preferences vary with species, habitat, and even individual temperament. Some octopuses appear to favour certain hunting grounds, returning to the familiar spots where they've had success in the past. This suggests not only memory, but also a concept of territory, of experience, and even a sense of risk versus reward. And when the octopus does hunt a clam or mussel, prey that cannot run but hide inside a hard shell, it shows yet another layer of problem solving. If brute force fails, the octopus may patiently drill a tiny hole into the shell using its beak, then inject a venom that relaxes the shell's muscles, allowing it to be opened effortlessly. This process can take several minutes, sometimes even longer, but the octopus persists. It is patient. It understands that effort will be rewarded. Few predators exhibit this level of persistence combined with specialized technique. At night, when many of the reef's residents have gone still, the octopus becomes more active. It leaves the safety of its den and begins to roam, using its excellent vision and sensitive arms to navigate the moonlit world. Underwater lights have revealed the mesmerizing sight of an octopus drifting like a ghost, arms trailing behind, skin changing color and texture in a slow, hypnotic rhythm. When it spots movement, it freezes, waiting for the perfect moment to strike. But even in the act of hunting, the octopus remains alert to its own vulnerability. It constantly scans for signs of danger, ready to disappear in a cloud of ink or slip silently into a crack. Every movement is a balance between hunger and survival, between risk and reward. This awareness, this dual focus on prey and predator, is part of what makes the octopus such a successful and elusive hunter. There is also an elegance to the way the octopus hunts, a fluidity that comes not from strength but from understanding. It learns from its environment. It remembers what worked before. It adjusts its tactics to suit the situation. It doesn't just follow instinct, it experiments, improvises, and refines. It is both artist and predator, both student and master of the sea. And perhaps most beautifully, it does all of this in silence. No roars, no cries, no splashes. Only the soft touch of an arm, the gentle bloom of skin changing hue, the quiet calculation of a mind at work beneath the waves. The octopus teaches us that hunting need not be violent or chaotic. It can be thoughtful, deliberate, and graceful. To watch an octopus hunt is to see a kind of underwater dance, a choreography of patience, precision, and perception. It reminds us that intelligence takes many forms, and that sometimes the sharpest minds are found not in towering creatures of strength, but in soft bodies that slip through the dark, sensing the world one careful touch at a time. The octopus is so strange, so intelligent, and so unlike anything else in the animal kingdom that it has often been described as alien, not just in appearance but in essence. Its body is a shape-shifting marvel, its nervous system decentralized and mysterious, and its behaviors wildly complex. And yet, it is also a product of Earth's evolutionary tree. But here's the most extraordinary thing. The octopus didn't just evolve intelligence. It evolved it completely independently from humans, dogs, birds, or any other creature with a backbone. It is the result of a separate evolutionary experiment, a biological journey that began hundreds of millions of years ago and somehow arrived at something uncannily familiar and yet fundamentally different. The octopus is a living answer to one of biology's greatest questions. How many different ways can nature build a mind? To understand this, we have to go back in time, far back, some 100 million years, to a world before fish, before insects, even before complex plants. Somewhere in the soft primordial oceans of ancient Earth, a common ancestor split into two great lineages. One would give rise to vertebrates, fish, reptiles, birds, mammals, and eventually humans. The other would evolve into invertebrates, jellyfish, worms, insects, and among them, a little-known group called the mollusks. Most mollusks didn't go far in terms of cognitive complexity. They developed strong shells, slow movements, and simple behaviors. Clams, oysters, and snails represent this group well, creatures that survive through defense and passivity, not thought. But one branch of the mollusks took a very different path. It abandoned the shell. It became fast, flexible, and curious. It moved through the water like a ghost. These were the cephalopods, the group that includes squids, cuttlefish, and the most enigmatic of all, the octopus. Why did this one lineage become so intelligent when so many of its relatives remained simple and stationary? The answer may lie in the evolutionary pressures it faced. Without a shell, the octopus became highly vulnerable. It couldn't rely on armor for survival. Instead, it had to outsmart its enemies. It had to hide, flee, deceive, and trick. It had to become clever. And so, over millions of years, its nervous system grew more complex. Its brain expanded. Its senses sharpened. Its behaviors became more flexible, more exploratory. Unlike most invertebrates, the octopus began to learn from experience. It could remember what worked and what didn't. It began to solve problems, to anticipate outcomes, to adapt its behavior to changing circumstances. In evolutionary terms, it began to develop something astonishingly close to what we call intelligence. But what makes this truly remarkable is that it happened without the usual building blocks of intelligence found in vertebrates. The octopus didn't evolve a spinal cord or a neocortex. Its neurons are shaped differently. Its brain is arranged differently. Even the structure of its learning and memory systems is different. It is not a copy of human intelligence. It is its own thing, grown from the ground up in the crucible of survival. In some ways, this makes the octopus more valuable to science than any primate or dolphin, because it shows us that intelligence is not a fluke or a one-time miracle. It is a convergent feature, something that nature can discover again and again under the right conditions. The octopus is living proof that complex minds are not confined to a single blueprint. They can arise from soft-bodied sea creatures just as surely as they can from apes. The structure of the octopus brain reflects this alien lineage. It is shaped like a donut, with its esophagus running through the middle. It has large optic lobes for processing vision, even though its eyes evolved separately from those of vertebrates. Its memory centers are different, its motor circuits are different, and its limb control is entirely unlike anything seen in land animals. Its distributed intelligence, with over 2/3 of its neurons located in its arms, is a biological innovation we still struggle to fully understand. But despite these differences, the octopus shows behaviors that we instinctively recognize as intelligent. It explores with curiosity, it manipulates its environment, it remembers past experiences, it can learn by watching, it can solve puzzles, escape enclosures, and even interact with individual humans differently based on familiarity. These are not behaviors that can be explained by instinct alone. They are signs of cognitive flexibility, the ability to change, adapt, and learn, even in novel situations. This independent evolution of intelligence also raises profound questions about the nature of consciousness. What does it mean to be aware? To have a self? To make decisions? If an octopus can do these things without a central brain structure like ours, then consciousness itself might be broader, more varied, and more mysterious than we imagine. Perhaps our human perspective is too narrow. Perhaps there are many ways to be aware, many forms that mind can take. Some researchers have even speculated that the octopus might experience something like subjective awareness. We don't know, and we may never know. But when we watch an octopus exploring a new environment, testing, watching, responding, we see a kind of purposefulness that feels familiar. We see decision-making, preference, mood. And while we must be cautious not to project human feelings onto animals, we must also remain open to the possibility that other creatures have minds of their own, different from ours but no less real. The octopus reminds us that life is inventive, that intelligence is not an exclusive club reserved for creatures with bones, that the universe is capable of producing mind through many different paths. It humbles us, it expands our definition of thought, and it invites us to imagine other worlds, other planets perhaps, where minds might arise in equally strange and beautiful forms. In the octopus, we see what happens when nature dreams in fluid motion, in soft tissues, in arms that think and skin that sees. It is not a lesser mind. It is not a primitive mind. It is simply another mind, grown in the deep, honed by necessity, and alive with a wisdom all its own. It is the product of a separate history, a different destiny. And in its presence we are reminded that we are not alone in the universe of intelligence. We are not its only expression. We are merely one voice in a great, quiet chorus of awareness that spans the sea, the land, and the far edges of possibility. Deep beneath the surface of the sea, where light filters in only faintly, and the world is cloaked in flickering blue and green, the octopus finds a quiet place to rest. It curls its arms around the entrance to its den, pulling in shells or stones to block the way, creating a safe chamber of solitude. Its skin slowly shifts to match the colours of the seabed, mottled browns, soft greys, perhaps a shimmer of faint coral pink. Then, as the world outside goes still, something remarkable begins to happen. The octopus begins to dream. At least that's what some scientists believe. In recent years, researchers observing octopuses during sleep have documented behaviour that is as intriguing as it is mysterious. As the octopus rests, its body seems to slip into a deeper state. Its breathing slows, its movements become minimal, and then, suddenly, without warning, its skin begins to ripple with changing patterns, spots, stripes, flashes of colour, shifting across its body in waves. Textures rise and fall, the octopus twitches gently, its arms undulating in slow, unconscious rhythms. These moments of activity are brief, lasting only seconds, but they repeat in cycles. To the casual observer, it appears as though the octopus is replaying fragments of memory, perhaps moments from earlier in the day, a successful hunt, an escape from danger, an encounter with a strange new object. The patterns on its skin seem to tell a silent story, a story only the octopus knows. This phenomenon has led many to wonder, do octopuses dream? Do they experience something like the rapid eye movement, REM, sleep that we humans associate with dreams? Do they relive experiences process emotions, consolidate memories? And if they do, what could their dreams be made of? Octopuses, like humans, exhibit distinct sleep states. Studies have shown that they cycle between a quiet, still sleep and a more active state, during which their bodies display dramatic changes in skin coloration and muscular twitching. These alternating states are strikingly similar to the sleep cycles observed in mammals and birds, including REM sleep. And while it's difficult to determine whether these states involve conscious dreaming, the pattern strongly suggests that some form of neural activity is taking place. Activity complex enough to trigger a cascade of colour and movement. But what is even more extraordinary is the sheer expressiveness of the sleeping octopus. When awake, an octopus uses its skin like a canvas to camouflage, to communicate, to mimic, and to hunt. When asleep, that same canvas becomes a reflection of the inner mind. In a sleeping octopus, the boundary between thought and body, between feeling and form, becomes almost invisible. If it is dreaming, then it is dreaming in colour, in shape, in skin. One particularly famous video, shared by marine biologist Dr. David Scheel, shows an octopus in a resting state, her colours shifting through a series of striking changes: pale white, stormy grey, spotted brown, vibrant flashes of yellow and black. As she lies still, seemingly unaware of the world outside, her skin tells a story. Scheel narrates, "You're seeing her change colours, as if she's hunting in her sleep. You can almost imagine her stalking a crab, camouflaging, then striking." The imagery is powerful. It invites us to see the octopus not just as a biological machine, but as a creature with an inner life. The implications of this are profound. Dreaming, in animals, is often associated with memory consolidation, learning, and emotional processing. In humans, dreams help us make sense of our experiences, sort through emotions, and even solve problems. If octopuses experience anything similar, it suggests that their minds are not only capable of intelligence, but of reflection, that they are not just aware of the world while awake, but perhaps even when at rest. This idea aligns with other evidence of the octopus's cognitive depth. Octopuses are known to navigate mazes, solve puzzles, and remember solutions. They adapt their hunting strategies based on past experiences. They recognize individual humans. They learn quickly and retain knowledge. All of this suggests that memory is a vital part of their mental world. And if memory exists, it is not unreasonable to imagine that memory might replay itself, even in sleep. But the idea of octopus dreams also challenges our understanding of consciousness. Most non-human animals do not show signs of having vivid, expressive sleep states. Mammals, birds, and a few reptiles show something akin to REM sleep, but in vertebrates. Until recently, the idea would have seemed absurd. And yet, here is the octopus, an animal with no shared evolutionary brain structure with us, displaying behaviours that suggest it might feel, remember, and reflect in ways we never imagined. Of course, we must be careful. The octopus's colour changes during sleep may not be proof of dreams. They might be a side effect of neural activity, a reflexive echo of waking life. We cannot ask the octopus what it experiences. We cannot know for sure if there is a dreamer inside, but the signs are tantalizing, and they point to a reality in which complex inner lives are not unique to us, nor even to creatures with spines. They may belong quietly and beautifully to those who drift in the depths, who touch the world not with hands but with arms that think and feel. To imagine the dreams of an octopus is to enter a realm of alien beauty. What would such a creature dream of? The feel of a shell beneath its suckers, the glimmer of a fish darting through shadow, the thrill of escape, the echo of a coral reef at twilight? Or perhaps it dreams in ways we cannot understand, of movements without form, of sensations without images, of instincts so ancient they defy our vocabulary. In the silence of the ocean night, an octopus curls into its den. Its body softens, its arms fold inward, Its skin shimmers with colour, and in that moment something stirs within it, something that may be a dream, a flicker of memory, or the ocean's own reflection in a thinking mind. Whatever it is, it reminds us that life is deeper than we know, that consciousness, in all its forms, is as wide and mysterious as the sea itself. The life of an octopus is short, almost heartbreakingly so. For all its intelligence, curiosity and complexity, for all the time it spends learning, hunting, solving, exploring, most octopuses live only 1 to 2 years. Some species live even less. Only a few, like the deep-dwelling giant Pacific octopus, can stretch their lives to 4 or 5 years, and even that is rare. Their lifespans are brief, fleeting, like waves that rise and vanish before anyone notices. And yet, in that short time, the octopus lives a life as rich, as purposeful, and as poignant as any creature on Earth. This contrast between the depth of the octopus's mind and the brevity of its existence has puzzled and saddened scientists for decades. How could a being so intelligent, so capable of learning and adapting, be given so little time? Why would nature invest so much in a mind only to let it fade so quickly? The answer lies in the strange, beautiful, and ultimately tragic biology of the octopus, a creature caught in a delicate balance between survival, reproduction, and decay. The octopus begins life as a speck, a single egg drifting in the sea, laid among thousands, sometimes hundreds of thousands, by a mother who will never see her young grow. After mating, the female octopus retreats into a den and attaches her eggs to the ceiling in long, delicate strings. She then begins the final chapter of her life. She stops hunting, she stops eating, she devotes herself entirely to her offspring, gently cleaning the eggs with her arms, fanning them with water to keep them oxygenated, guarding them night and day against predators. During this time the mother wastes away. Her body begins to break down, quite literally. Her muscles atrophy, her skin fades. She withers slowly, refusing all food. In a process scientists call semelparity, or one-time reproduction, she sacrifices herself completely to give her young a chance at life. It is not just exhaustion, it is biologically programmed death. Her optic glands, which function like the mammalian pituitary, begin to release signals that trigger the body's shutdown. Even if food is placed nearby, she will not take it. Her focus is absolute. Then when the eggs hatch, she dies. The male too has a short fate. After mating, he gradually loses strength and coordination. His body begins to deteriorate. He becomes less alert, less responsive. Eventually he dies alone, often drifting in the current, vulnerable to predators. There is no courtship, no pair bonding, no parental care beyond the mother's vigil. The entire life of the octopus is geared towards this single act of reproduction. It is a life of intensity, of brevity, of urgency. But what a life it is! In just a year or two, the octopus experiences the ocean in ways few creatures can. It explores not in linear paths, but in swirling spirals of curiosity. It learns, adapts, hides, escapes. It plays, it tricks, it solves, it invents. It is a creature that lives fully, not just biologically, but cognitively. Some researchers have likened the octopus to a spark, bright, quick, and brilliant, then gone. And in that flash of time it accomplishes what some animals never achieve in decades. There is also something inherently poetic in the octopus's short life. It reminds us that meaning is not measured by length, that richness does not require years. The octopus does not pace itself. It lives with intensity. It spends everything. Every movement is part of its learning, every encounter a risk and a lesson. It cannot afford to delay its exploration or its growth. Every moment matters. And for the octopus, aging is not a slow decline. It is a sudden, irreversible transformation. In the final days of its life, the octopus may show signs of what scientists call senescence, a terminal decline that includes disorientation, erratic movement, loss of coordination, and sometimes self-injury. These behaviours, though distressing to witness, are not signs of failure. They are part of the natural ending written into its biology. They are the final expression of a body that has poured all of its energy into reproduction and has nothing left to give. Some scientists have experimented with removing or disabling the optic glands in female octopuses to delay this process. Without the hormonal signal to begin the death sequence, the females live longer, eat again, and regain their strength. But they never return to their eggs. Without death, the maternal drive is broken. The octopus's life is extended, but its meaning is blurred. This reveals something profound, that the octopus's life is not just short by accident, but by design. Its entire arc, from hatching to discovery to reproduction to death, is an exquisite loop of purpose. A life lived not for longevity, but for contribution, for leaving behind the next generation, for adding to the ocean a new wave of thinkers, swimmers, and dreamers. There is a quiet sadness in this, but also a kind of peace. The octopus is not afraid of its end. It does not resist the cycle. It lives as it was meant to live, deeply, briefly, completely. And in that surrender to time, it becomes a mirror for us. It reminds us that we too are temporary, that we too must make meaning not from how long we live, but from how fully we inhabit our time. To see an octopus near the end of its life is to witness something sacred, a being that has spent itself in the service of life, that has given everything it had to the sea, and that now drifts, not in defeat, but in completion. It has known freedom, it has known danger, it has known curiosity and hunger and wonder. And now it fades into the depths, leaving behind thousands of tiny lives to continue the story. In its short time, the octopus has shaped the ocean in small, beautiful ways. It has moved through it like a whisper, like a poem. And though it is gone quickly, it is not forgotten. Its impact ripples outward. In the shells it leaves behind, in the minds it has touched, in the mystery it continues to inspire. It is a reminder that even the briefest lives can be luminous, that even the softest voices can echo, that even 1 year beneath the sea can be enough to change everything. As we slowly ascend from the depths and leave behind the octopus's secret world of shifting colour, fluid motion, and quiet intelligence, we're left with a lingering sense of awe. The octopus is not just a creature of the sea, it is a question wrapped in arms, a living riddle that defies our expectations of what animals can be, what minds can do, and how life expresses itself when given the freedom to evolve in an entirely different direction. It is at once familiar and alien, elegant and eerie, playful and profound. And as we return to the surface, we are not the same as when we first descended. The octopus has taught us many things, not through language, not through sound, but through action, adaptation, and presence. It has shown us that intelligence does not need bones or a spine or a face like ours. It can live in a body that flows like water, that sees with its skin, that tastes with its arms, and that thinks not just in a head but throughout its form. It has reminded us that life is not confined to a single pattern, that nature is capable of inventing awareness again and again, sculpting it into new shapes, new strategies, and new forms of beauty. We are used to looking for intelligence in animals that resemble us, those with expressive eyes, familiar body language, social bonds, and clear vocalizations. But the octopus invites us to broaden that lens, to consider that the mind may exist in forms far removed from our own. It asks us to pay attention not only to the obvious signs of thought, but to the quiet ones, the careful twist of an arm, the planning of a silent escape, the subtle shift of colour that signals mood or intent. In the arms of the octopus, we see motion that is not just mechanical but meaningful. We see learning that happens through touch, through interaction, through problem solving in real time. And in its brief, brilliant life, we see a reflection of our own desire to understand, to explore, and to find our place in a world that is larger and stranger than we can imagine. Perhaps the most enduring lesson the octopus gives us is that awareness takes many shapes. It is not a single flame burning in one kind of body, but a spectrum of sparks, each alive in its own way. For the octopus, awareness is expressed through a distributed network of neurons, through coordinated movement, through the capacity to change in response to the environment instantly. It is an awareness that does not cling to form but flows through it, that does not resist change but is change. There's something deeply humbling about this. The octopus is not trying to dominate the ocean. It is not building empires or manipulating ecosystems. It simply exists, attuned to its world, responsive, fluid aware, and in doing so it has achieved a kind of quiet mastery, the ability to move through life with grace, to meet each challenge with adaptability, to survive by being soft rather than hard, mysterious rather than loud. In a way, the octopus embodies the very essence of nature's wisdom. Not the wisdom of control or permanence, but the wisdom of being present, of adapting, of moving with the current instead of against it. Its body is a lesson in flexibility, its mind a study in humility, its entire existence a meditation on the power of transformation. And so, as we rise back to the surface, whether literally or metaphorically, we do so with something new in our hearts, a deeper appreciation for the unfamiliar, a renewed curiosity for the world around us, and perhaps a sense of reverence for a creature that, though it may never speak to us, has shared with us a silent, powerful message. That intelligence does not need to be loud, that wonder does not need to be explained, that life in all its forms is far richer, stranger, and more interconnected than we often remember. Maybe the next time we see a tide pool or a documentary flickers across the screen showing arms twisting through coral, we will stop and feel a quiet recognition, not of a pet or a peer, but of a fellow traveller on this strange spinning planet. A creature who, like us, was born into a world it had to make sense of, who in its own language of touch, colour and silence asked the same ancient questions we do. What is here? What is safe? What is possible? And perhaps the octopus, in answering those questions with its arms and its instincts, has taught us something we didn't know we were seeking. That to be truly intelligent is not always to explain, but to feel, to adapt, and to live fully, even for just a moment in time. So as we float back to the surface, the current soft around us, the colours of the reef fading into memory, we carry with us the echo of the octopus's world, a world of stillness and motion, mystery and meaning, awareness without words. And though the ocean may close behind us quiet and wide as ever, the impression remains. A gentle presence, a hidden brilliance, a mind in the deep,